Hey guys. Um, so last time we spoke, I left you with this. Let's see if you named it right. I hope you didn't fall into a trick here, huh? How many of you said isopropyl? My answer would be no. I hope the answer would be nobody. Watch this. There's no isopropyl. There is no isopropyl. Because that's your longest chain. What I do have is a couple of methyl. That's what I have. So be careful. Okay, will I do this to you on a test? Of course I'm going to do that to you on a test. Why not? Be glad I did that to you on an example before I give it to you on a test. Trying to don't let me trick you twice. But I'm sure you guys didn't got tricked on that one. I'm sure all of you said that was my longest chain. And all of you said this is number 1, 2, 3, 4, 5. It's a 9 carbon organic compound, not 8. I have confidence in you. Alright, 2-bromo, 3 cyclohexyl, 7,8 dimethyl. So remember from last time, since there's triple bond and double bond involved, we go non, and within this non, there's a triple bond at number 4 position, and there are double bonds at number 2 and number 6 position, which we will have to indicate the di before the ene. Right? So, hey, be happy the fact that you got this. If you haven't, just correct yourself. You'll be fine. All right, so, hey, ready for the next functional group? The functional group that we're going to look at next is no quadruple bond if you're thinking about it. We know that doesn't exist. We play with the molecular kit around October. We know that it can't happen. So your next functional group is my personal favorite, alcohol. Okay. Now, within the priority chart, do you remember a priority chart that I introduced you to last week? And we have alkyl down here, and then we have alkyne, and then we have alkene. Well, alcohol is more important than alkene, and it deserves a nice spot up there on top of alkene. Okay, so the priority chart, again, it will be something that we will look into every time we start a new functional group, because we want to know where that stands. So, alcohol, most important group as of this moment. This is our fourth functional group. So, being the fourth functional group, what can we say about alcohol? Well, an alcohol consists of an organic group. Now, R, which I haven't introduced you to before, at least not in chemistry. You might have seen it in biology. R stands for hydrocarbon. Now, it doesn't always have to stand for hydrocarbon. It can actually stand for any psi group. Okay? Now, we're not going to get into that because that becomes too complicated. But what is this hydrocarbon bonded to? Well, it's bonded to an OH. Now, we've seen OH before, but last time we saw OH, it was bonded to a metal, like NaOH, KOH, FeOH2. We call those bases because they're proton acceptor. But not this time. Okay? These are alcohol. In replacement of the metal, we have a hydrocarbon. Okay? And let me tell you right now, remember NaOH dissociate in water? You put this guy in water, it just becomes an aqueous thing because alcohol dissolves in water. Why? Because the OH turned this whole molecule into a polar molecule. Okay? Of course, this is due to the difference in electronegativity, which we learned way back when we looked at periodic trends. Okay? So everything that we've looked at so far, alkene, alkyne, alkyl, they're actually nonpolar. Okay? They are not going to dissolve in water. Alcohol is polar because, very simple, it has an OH. Okay? But however, the longer the R group, the less polar this thing is going to be. Okay. All right? So that's just something to keep in mind. We know that polar and polar will mix. So alcohol mixed with water is going to form a solution. It's not going to form layers unless this alcohol has a long, long, long chain. All right? So just something that we already know and something that I kind of want to bring back. Okay, just to tie in things that we learned from the past to something that we're learning right now in the present. So that's alcohol. Okay, the property of alcohol is that it has a hydrocarbon end and an OH, which is polar on one end. So you'll see OH a lot. Okay, bonded to organic chemicals. So today we're going to look at some examples of alcohol. We'll look at the very first one carbon alcohol. Okay, we have a methyl group right here. The C is bonded to 3 H's and it's going to bond it to an OH. Okay, now the question is, how are we going to name something like this? Well, it's very simple. We named the amount of carbon it has, so that's meth. Stands for 1. Now, we're going to keep the AN. We're going to change the E. And we're going to replace the E with an ending OL. So this guy is called methanol. Okay? Be careful of this stuff. This stuff is pretty dangerous. Too much of it, okay, just smelling too much of it, it can actually make you go blind. A lot of places have this to wash glassware with, but we don't have it. I checked, okay. I know somebody knew I checked, and we don't have methanol. Well, what we do have, I know Mr. Chung has lots, is this one. 2 carbon alcohol. So if 1 carbon alcohol is called methanol, 2 carbon alcohol must be ethanol. This is your drinking alcohol, which none of you know anything about because you guys are underage. I guess I've never tasted before, and you don't want to. All right, ethanol, 2 carbon alcohol, and if you were to increase the carbon length to 3 carbon in a straight chain, we call this propanol. Okay? And that's where the nightmare begins. I didn't really need to do that, actually. Just go down. Why did I say this is where the nightmare begins? It's because this is not propanol as is. I'm going to tell you what this is. This is called 1-propanol. And hopefully you know why I say that. And hopefully, if I were to do this to you, which is move the OH here, instead of OH being bonded to this carbon at the end, I'm going to have this OH bonded to the middle carbon. What would you call that? Huh? Well, I'm sure you guys will say something like 2-propanol. If I ask you why, you'll say, well, if I were to say this is my longest chain, maybe 1, 2, 3, like this. That's right. You do that. Just like what we saw with alkane and alkyne, you want your most important functional group to inherit the lower number. Since the alcohol group OH is in the middle, there's really no need to determine if you're going to go left to right or right to left, because it's going to be the same. But later on, it will make a difference, of course, when they're not the same. So this is called 2-propanol, and of course these are isomers. Now, they have a different name for this guy. Okay, do you remember a side group that looked like this called? Do you remember what he's called? That's right, isopropyl, huh? This is actually an isopropyl group. See the CH? See the 2 CH3? Oh, I've heard of this. I have this in my medicine cabinet. And other than 2-propanol, people call this isopropyl. Sorry, isopropanol. So 2-propanol is really isopropanol, because we know what isopropyl is. This is isopropyl. If you added OH at the end, that's an isopropyl alcohol. Isopropanol. What's isopropanol? Why is that popular? Because this is my rubbing alcohol. Don't drink that, eh? That's poisonous. Very good at killing bacteria. So, whenever you hurt yourself, scrape yourself, you got cut, you might want to put some rubbing alcohol around your wound, killing all the nearby bacteria so that you don't get an infection. Okay? That's going to sting though. It's better than getting an infection. Alright? So, let's go ahead and look at some isomers. Let's clear this page. And let's take a look at so here it is. Okay, a 4-carbon alcohol, which we know is going to be called butanol, right? No? Of course, 1-butanol. And of course, I can move that OH around, okay, to this. Of course, you will say 2-butanol because you're going to count from left to right. How about a 3-butanol? Nah, you can always count backwards. We know that trick already. Okay. What if we have this? Okay, some side groups involved. Now I'm going to be scared because there's side groups involved. No big deal. This is just going to be 1, 2, 3, 4, 5. Okay, so you have 4 chloro. Okay, 2 pentanol. Okay, 4 chloro, 2 pentanol. Hey, can I say this? Can I say instead of 2 pentanol, I say pent 2 all? Put the 2 before the all, get rid of the AN? Absolutely. Actually, in some cases, in some textbook, in some scientific journal, they do that too. Okay. Again, you're going to see where this will be done. Well, you have to do it. That's when we have double bond and triple bond and alcohol all in one, and that's when you'll have to do this. And are we going to see that? Of course we're going to see that. What kind of question is that? All right. Let me do a few more. Okay, no more hydrogens. Can't sick of drawing hydrogens. What if you have this? Be a methyl group right here. Multiple alcohol groups. Not going to scare you, is it? Well, here's my longest chain. And I need to make sure that the carbon bonded to the alcohol gets the lower number or the lower combination of number. All right. Number 1, I guess. Okay, because if you were to go this way, you're not going to hit alcohol until number 3. No, number 1 is much better than number 3. Why would you want to be number 3? All right, so that's 6-methyl. Okay, 1, 3, 5. Okay, 1, 3, 5. Hept. 10. Triol. Okay, now some people actually don't use the N. They said heptatriol. Some people say hep 135 triol. Does it make a difference? I don't think so. Okay, so 135 heptatriol, heptatriol, hep 135 triol, they're all good. Okay, so if you have multiple alcohol, all you have to do is just indicate where they are. Okay, they're positioning in the longest chain. Don't forget about the tri and end it with OL. Make sure you end it with OL. Okay, so let me give you this one. Goodness. Pause. Try to name this. Okay. Hopefully you unpaused and you gave me a nice name. Here's your longest chain. 1, 2, 3. Very simple. Okay. This is nothing more than 1, 2, 3 propanol. You've seen this before, haven't you? You've seen this. I'm sure you've seen it. Don't tell some people that you haven't seen it, or else something bad will happen to you. Now, the last time you saw this, you might have not seen it like this. You might have seen it like this. You might have seen it like this. Okay? You may have seen it flip, 45 degrees. Why? Because by flipping it like this, you can show a reaction with something called fatty acids. And usually the three of them, because that's popular in our body, especially in our adipose tissues. Now, can you tell me another name for 1,2,3-propantriol? Because commonly people don't say 1,2,3-propantriol. That's a mouthful of numbers and words. We gave him a very, very special name. Well, at least biologists did. We call him glycerol. Okay. Glycerol had the ability to bond with these fatty acids. Okay, in a reaction called condensation in chemistry, but I think in biology they like to call it dehydration synthesis, where water is made here. So the O connects to the H. Okay, water is made again here, water is made again here. Okay, to make something called triglyceride. Okay, if it's just one of these, it'll be monoglyceride. It'll be two of these, it'll be diglyceride. If it's all three sites doing dehydration synthesis, there's your triglyceride. That's fat. All right. Now, we'll come back to this idea of, this is called estification reaction. We'll actually come back to that maybe in a couple of weeks. Okay, so relax. Just remember that name. All right. Let's continue. Let's do this one. Okay, maybe we'll do this one too, just to make this a little bit more difficult. But you're probably thinking, that's not making it more difficult, just making it more annoying. All right, longest chain, no trick, right there. Oh, goodness. Right there. Okay, left to right or right to left? Well, of OH here, number 2, if I were to go the other way, OH is number 3, number 2 is better than number 3. So I would say left to right. All right, now you can start naming it. So it'll be 5,7-dibromo. Okay, 9,9,9-trichloro. There is a this over here, if you remember correctly, what that is just an isobutyl. Okay, 2, 3, 7 nona-triol. Okay. Guys comfortable with that? Okay. 2 more, and then we'll call it for the day. Trying to hit as many scenarios as possible. How about that? Now, in this case, the functional group is no longer a chain, but a cyclic molecule. But just because it's a cyclic molecule doesn't mean that we don't know how to apply cyclic rule, right? You make sure that the alcohol group's at number 1. And then you depend on if you want to go clockwise or counterclockwise, because if there is a second OH, you want that to be closer. Of course, you're going to go clockwise because that will give this OH number 2. 3, 4, 5, 6, which you really don't need to indicate. So something like this will be just 1, 2, cyclohexanol. Sorry. Sometimes I make that mistake. Cyclohexanediol. Right? So a cyclic alcohol, not much of a challenge if you think about it. So if I would give you another cyclic alcohol to do, with other things put into place, can you name that? Okay, I'm sure you can. But the hard part here is determining who gets to be carbon number 1. Right? Well, it's not really that hard if you think about it. This guy and this guy can both be potential carbon number 1. Let's just say you give it to this guy. Okay? Who would you give carbon number 2 to? Now remember, you want to see if there's another alcohol, and there is. It's right there. So you want to make sure this guy gets a lower number. So going this way will ensure that. Okay? So, alphabetically, you have 5-ethyl, 2-methyl, okay, 1,3-cyclohexanediol. All right. Just again, if you know how to name cycloalkane, this is really the same thing, but instead you're looking at things with an alcohol ending. All right. Oh, let's just move up. No more cyclic molecule. In fact, let's go straight to this. How would you name that? All right. As you can see, this is your longest chain. You want to make sure your longest chain, again, has to have an alcohol, has to have double bond, and it has to have triple bond. If you see another longest chain elsewhere, but it doesn't involve all of those double bond, triple bond, and alcohol, that's not your longest chain. So your longest chain has to have all of these, including your most important group, of course. Okay? And you want to make sure that this guy gets the lower number. But in this case, it's going to be 4 going this way, 4 going that way. Okay? But which way would you pick? Well, I hope your answer would be this way. And I hope your reasoning is because, hey, if hydroxyl is tied between both ends, my second most important group is double bond. I want to make sure double bond gets the lower number. Okay, in fact, here is 3 versus if I go this way, maybe 4. So let's take a look at how we're going to name this. By convention, it shouldn't be very hard. Okay, take care of those side group, 2-methyl. Okay, the side group is taken care of. Now, you want to look at your longest chain. Your longest chain is a hept. Okay, that will tell readers that this longest chain is 7 carbon long. What's in this longest chain? Well, there's double bond, there's triple bond, there's alcohol. Where am I going to go first? Well, you go with the least important first. The least important, of course, is triple bond, and that's at number 5 position, right there. Then it's double bond, and it's then it's double bond, right here. Then you end it with the alcohol. Just like that. So if you think about it, this whole thing right here is based on your longest chain. Okay? Within a longest chain that is worth 7 carbons long, there is a triple bond at position number 5, there's a double bond in position number 3, and there is an OH in position number 4. If you were given this, you should be able to draw the same thing. Okay? All right. Let me give you one for you to do for homework and see if you guys can figure it all out. So let's cancel this page. Let's do the ultimate question of all ultimate question. Okay? All right, draw that, name that, and we'll take it up tomorrow. Bye.